So at the top of your notes, you're going to see several different identities. Let's start with the first group. The first group is called reciprocal identities. What does the word reciprocal mean to anybody? Flipping a fraction, right? Flipping a fraction. Yes. So, do you remember cosecant? We learned about him back in right triangle trig. He was the reciprocal of whom?
Sine.
Sine. So you notice the relationship that they provide for you here is that cosecant is equal to 1 over sine. This is the same thing as me telling you they're reciprocals of one another. And secant's buddy was cosine, so they're reciprocals. And cotangent was the reciprocal of tangent. I'll be honest, this one is really never used. I shouldn't say never, but I'm going to put a little star next to never. Rarely, yes, rarely used would have been a better word. That's because this is typically the identity trade that we use for tangent. So instead of saying tangent is reciprocal of cotangent, we actually say that tangent is sine over cosine. Now when you take trig next year, you're going to understand more as to why tangent is sine over cosine. Actually, you guys might be able to tell me this. What section? 13.3. Does anyone remember the new formula for tangent I gave you besides the opposite and adjacent? Y over x. So what if I told you that on the unit circle, the y is the sine function and the cosine is the x function?
Tangent you lost because sine is opposite over adjacent and cosine is adjacent over hypotenuse and tangent is opposite over adjacent, so it's O over A.
Yeah. Cool.
Yeah, 'cause I'm cool like that.
You heard her. She just derived a formula for y'all. So, nice job. So, when you guys go to trig, you're going to go very deep into the unit circle and understand exactly how all the things work. So, right now, we're just giving you a very brief introduction. So, if all you memorize for me, and even you don't even have to memorize it. If all you write down in your foldable is tangent is sine over cosine, and you just know that whenever you see tangent, you can trade it for a sine over cosine, that's good enough for me today. Cotangent, therefore, would be cosine over sine. Someone tell me why that makes... Yeah, cotangent is the reciprocal of tangent. So they took the reciprocal. By the way, up here on the reciprocal functions, or the identities, what if I wrote sine theta equals? What could you replace with sine theta using this kind of idea?
1 over cosine.
Good, 1 over cosecant. And same theory here. What if I wrote cosine theta? What could I replace that with? 1 over secant. And again, the reason is they're just reciprocals of one another. And then we realize that we rarely use this one, so I'm not going to bother writing it down. So this is another one that we're going to often use in place of this one. And then here we have somebody called the Pythagorean identity. Pythagorean identity. Who do you think came up with these guys? Maybe Pythagoras? That's a person, you know, right?
Oh, made up God.
No, it's a math god, yes. Like a Greek god, like Zeus. There's Pythagoras up there on Mount Olympus, deriving formulas all over the place. Well, okay, just so we're all clear, Pythagoras was a person. He was a Greek mathematician, and he was awesome. So he's most famous for his Pythagorean Theorem, which has to do with right triangles. Now, remember what I told you about 2 minutes ago. I told you that the sine and the cosine were really x and y values. So if you know that, doesn't this look a lot like Pythagorean Theorem? X squared and y squared added together?
Yes.
And you don't know this about the unit circle yet, but in trig you'll learn that the radius of a unit circle is 1, and that's why it equals 1. Now, when you guys do go to trig, they will make you do a little bit of memorizing, so just watch out. But I only memorize this one because once you know this one, you know these other two. And you don't have to write this down, you can just watch. But if I took this whole identity and I divided everybody in... Whoa. Come back, pen. Oh, goodness. I hate when it does that. Okay. If I took everybody and divided in by sine squared. So everybody by sine squared. And they write squared before the theta. That's a weird trig thing. Can someone tell me what sine squared over sine squared would reduce to? It's a 1. Okay. Look above. What would cosine squared over sine squared reduce to? And first of all, what's cosine over sine?
opposite over adjacent. Cosine over
Cotangent. So if I square both of them, do you suppose that's cotangent squared? And then what do you think 1 over sine squared is?
1.
Well, what's 1 over sine?
Cosine.
So what do you think it is when I square it?
Cosine.
Cosecant squared. Very good. Does that look like one of these other two?
No.
Well, looks exactly like him, right? How do you think I could derive this one? If I divided everybody by a cosine squared, I'd end up with this formula. So when you get to trig and your evil trig teacher says memorize these, you don't actually have to memorize all 3 of them. You really just need to memorize the first one, and then you know how to get the other 2. So something to think about. And honest to goodness, guys, to this day, how many years have I been doing this math? A long time. I still don't have these 2 memorized. I never will have them memorized because I don't have space in my brain to memorize stuff I don't have to. Oy. Okay, I have these little identities at the top of each of my slides just for quick reference, but you guys might want to have them handy. If you've already written them and they're foldable, you're awesome, but otherwise you might have to flip the paper a little bit.
You're awesome.
Thanks. Let's start with simplifying. Okay, simplifying. We're going to do something called trig trading. And every time I see a trig function, I think about what I can trade him for. So let's start with example A, says cotangent of x. What can you trade for cotangent? And I know there's 2 different things. I could do 1 over tan. What else could I do? Yeah, right here. See this? Cotangent is really cosine over sine. So what I'm going to do is instead of writing cotangent, I'm going to use this one because I know it's going to work better. I'm going to write he's really cosine over sine. We're substituting in the equivalent part of the identity. Okay, talk to me about secant. What can you trade for secant? 1 over cosine. So instead of secant, I'm going to say times 1 over cosine. And now I want you to use your algebraic skills. What would happen if you just had this sitting on a piece of paper?
You can cross them out.
The cosines would cancel, and you'd end up with 1 over sine. Now, you guys aren't real familiar with this, but this is not the correct answer yet. There's something more simple that you can tell me besides 1 over sine. Cosecant. Nice job. That is the correct answer. Do you remember doing proofs in geometry? And you kind of were irritated because you had to show a lot of steps and things? You need to show a lot of steps on these too. So when in doubt, show more work than you think you have to show, okay? Letter B. There's a weird little, when I took the picture, I had the cursor sitting here, so that's why there's a weird looking 1. Cosecant. Oh, I know, but my screen does. Cosecant. Can you trade cosecant for me? Cosecant? 1 over sine. That makes sense. And give me a trade for tangent. Okay. And then I know you're like itching to cross things out, but hold on, let me catch up. What cancels?
Sine.
The sines will cancel, and you'll be left with 1 over cosine, and I know you guys know you're not done. He is secant. Very nice. So the most simple answer you can give me would be your final answer. And I think we can all agree, fraction, not good. We would like a...
Put that on the, homework. We just put 1 over cosine.
Well,
It's just more simplified.
most of your questions on your homework are not going to be this. Most of your questions on your homework are going to be trig identities, which we're going to look at in a second. So we will find out why we won't have that problem on trig identities in just a minute. Okay, and letter C. Does anyone have any algebraic instincts right here on the numerator? Just cross it off? No.
Why not?
Okay, very nice. Distribute them or FOIL them, if you will. Do you see this? What would be secant times secant? Secant squared, and now we know they write this kind of weird. They write secant and then a squared and then the x. Now don't write this part down. Let's just think about it. On the outside, you're going to have negative secant, and what happens on the inside? Positive secant. They cancel. And then 1 times negative 1 is minus 1. All right, good news. The denominator is still tangent though, right? I'm just going to leave them as tangent for now. The more of these you do, the better you'll be at knowing when to trade things and when not to trade things. Okay, just look at the numerator for me. I think he's something very special.
Everyone's very special.
I think that he is some strange manipulated version of this formula. 1 plus tangent squared equals secant squared. How could I rearrange this formula to make it look like secant squared minus 1 just on one side? Could I just subtract the 1?
Yes.
And then you're left with tangent squared, and you can put theta or x, it doesn't matter, is the same thing as secant squared minus 1. So now tell me, what can I trade for secant squared minus 1? What's he equivalent to? Tangent squared. Okay, I'm really glad I didn't trade tangent yet.
How is that secant squared with tangent squared?
I took this equation and I subtracted a 1 to the right side, and then I got tangent squared equals secant squared minus 1. So that means when I saw secant squared minus 1, I could trade him for tangent squared, because he's equivalent to secant squared minus 1.
So basically you just like...
It's substitution, essentially, is what it is. When I used to tell you guys x equals 3 and you guys plugged in a 3 for all your x's, it's the same idea. It's just what we're plugging in, not pretty.
So how do you know when to trade?
Practice, practice, practice. Yeah, these get easier with practice, and I'm not going to give you guys real hard ones, so don't freak out. But I don't think we're done. If this was like x squared over x to the first, what would you do? Cancel one of them, right? So same idea. One of the tangents will cancel, and your answer is tangent. Fun times.
That's weird.
I know. Okay, do me a favor. Flip to, I think it might be on the back of this page or somewhere. It says practice 14.3. Is it on there? Next page, okay. Flip till you find it. Practice 14.3. This is actually going to be a homework assignment, so I'm not going to do all of them for you, but please notice that on these first 3 problems, they just want you to simplify. So you trade what you can, cross out what you can, and then write the most simple answer you can think of. I'm not really worried about number 1. I think you'll do it fine. What are you going to trade number 2 for? What's secant? 1 over cosine. What's tangent? And you can just look above on my slide. Tangent is sine over cosine. And then cosine is cosine. I'm going to keep them that way. The kind of the rule of thumb is trade everybody for sines and cosines and then see what happens. Now, at the end, you might need to trade back for a tangent. For instance, here, do you guys notice that 1 cosine will cancel? I don't care which one you cancel, but one of them will cancel, leaving you with just sine over cosine, which is tan. So this is a case where we end up back with a tangent, but we had to trade them at first to see what canceled. What do you think? What? Remember, sine's a function. So if I had like logarithm of 2, logarithm of 4, the 2 and 4 don't cancel because they represent a function. What do you think you're going to do on number 3? Algebraic instincts? Yeah, distribute. It's another FOIL problem. So I think this is a case where the outer and the inner will cancel out again, and you'll get sine squared minus 1. Now, I can promise you you're not done. I think this guy, if I move a couple things around, looks a lot like this guy. Okay, think about some movements that you can do to make the left-hand side of this equation look like this. So what would you do? You'd have to subtract the 1 and also subtract the cosine squared. See that? I should have written this a little bigger, but yes. Ms. Taylor says, does that mean you get negative cosine squared? Yes, you do. So you can't see it because I wrote really sloppy, but it says sine squared minus 1 equals negative cosine squared. So what that means is whenever you see a sine squared minus 1, which we do, you can trade him for his equivalent, negative cosine squared. That's a hard one. Even kids in trig struggle with that one. So what I might suggest you do on your foldable, if you have room, you can take that identity and you can manipulate him various different ways to show what he's equivalent to. So like what happens when you subtract the sine squared, what happens when you subtract the cosine squared, and you add the 1, what's going on. You don't have to, but maybe as you do your homework problems, if you do manipulate it, just write that one down on your foldable somewhere underneath the other ones. Okay. Back to your notes now, please. The next section of your notes says verifying identities. What was the question? We haven't done those yet. Okay, verifying identities is the same thing as me saying basically prove this to me. And I know the word proof sends chills down some of your spines, but we can do this. Proofs are not bad, especially in trig, especially in algebra, because algebraic proofs just use the same properties you've always done ever. So substitution property, there's some, addition properties that you need to think about, multiplication. It's the same properties that you guys do every single day. We're just doing it in a more formal notation. So one rule, you must show all of your trades. So you can't start with the first thing and then skip 4 steps and then just tell me the answer is this equals this. You have to show everything, which I know irritates some of you. And when we do a trig identity, you never touch the right-hand side. And I'll show you what that means right now. So, letter A, we're going to verify that tangent x times cosecant x is the same thing as secant. So what I like to do is I draw a line through my equal sign. This is the left. This is the right. And remember the rule? Never touch the right-hand side. What that means is you don't trade anything for the right-hand side. What do you think the very last line of my identity is going to look like? Secant x equals secant x. Okay, a little weird. Okay, let's start on the left-hand side. Can you trade tangent for somebody? Sine over cosine sounds like a plan. Okay, can you trade cosecant for me? 1 over sine. And I know some of you are looking ahead and you're like, I'm done. No, you are not. The right-hand side needs to say this, equals secant x. Okay, now what cancels? Sine. And I know some of you go, done, secant equals secant. No. What's your next line look like? 1 over cosine should equal secant. Now what's your last line look like? Secant x equals secant x. So the final line is not what impresses me. It's your work to get to the final line that I'm going to be looking for. And some of you are going to be very sad when you try your homework and you make some logic jumps that you can't make. You got to show them, okay? Very important. So letter B. Can't touch the right-hand side. Well, that's kind of good because I have no idea what to trade a 1 for. So let's start on the left-hand side with tangent. Trade tangent for me. Sine over cosine. Okay, how about cosecant? 1 over sine. And how about cosine? That's nothing to trade. We're just going to leave it as cosine. I'm going to put him over a 1 though, because I get a little confused otherwise. And then on the right-hand side equals 1. Okay, now for the fun part, what cancels? Sine cancels, cosine cancels. This is a case where you're actually done. What's your answer? 1 equals 1.
Why did you keep it as cosine over x over 1?
Well, what were you thinking to trade cosine for? I mean, you could do 1 over secant, but that would kind of get us back where we started, so. The idea is you usually want to trade everything for sines and cosines. Once you do that, then you start canceling, generally. Not always. Like we saw an example a while back where we did not want to trade tangent. So, okay, part C. This one's going to take a little bit of writing, so make sure you write kind of small. I'm going to actually go up here for a second. Okay. Sine x divided by cosecant x. Okay, sine's fine. But what's cosecant? 1 over sine. Okay, I'm going to leave cosine squared for a second because I don't know what he's going to be. And this should always come out to equal 1, apparently. I want you to go back to 5th grade. When you divide sine by 1 over sine, what are you really doing? Multiplying by this reciprocal. So what you're really doing is taking sine and multiplying it by another sine. Agree? Okay. And sine times sine is sine squared. Oh, I see the light at the end of the tunnel. What is sine squared plus cosine squared? 1. And that I covered it up with my other slide. But
Is that, did we do that on
did we do that? Okay, Pythagorean identity, I covered them up, but right here, you guys have sine squared plus cosine squared equals the number 1, which means that if you ever saw sine squared plus cosine squared, you could replace it with 1. Ta-da! I see it, so I replaced it. Okay? These will become much better with practice. I know it's kind of strange right now. Some of them are easier than others, I will agree with you. The reciprocal ones seem to be pretty easy to trade, and tangents easy to trade. Once we start talking about Pythagoreans, then we get kind of crazy. Okay, letter D. Split this into 2 columns. All right, let's have fun. Cotangent. What is cotangent? It is 1 over tangent, but I don't like that one so much. Cosine over sine might be better. And then it's times a cosine, so I'm going to put him over a 1 so I don't get confused. And then everything there is still being divided by cosecant. Can you trade cosecant for somebody? 1 over sine. Okay. This one won't be as fun, guys, so hang on. What happens up in this original numerator? We got cosine over sine times cosine. If I push those together, you have cosine squared over sine. Okay, so I'm going to write down cosine squared over sine. All that is this numerator. He's still being divided by what? He's still being divided by 1 over sine. Can we take a little bit of a shortcut? Can I change that to a multiplication problem? Yep. I don't think I can without, I can extend the page, maybe that'll help. Is that better? Okay. So if I divide by 1 over sine, that's really multiplying by the reciprocal, which is sine over 1.
So then they cancel out, right?
So tell me what happens.
It's cosine over 1.
Okay, the sines cancel, and you have cosine squared should equal 1 minus sine squared. Okay. Remember that Pythagorean identity I accidentally covered? I think that if you guys could solve for cosine x, I think we'd be done. Rearrange this identity so it says cosine x equals. What would you do? You'd subtract the sine squared over, right? I think we're done. Is cosine squared equal to 1 minus sine squared? Okay. So our final line says sine squared, 1 minus sine squared equals 1 minus sine squared. So you definitely know if you did it right, because if you get to the last line and you can't get it to equal, then something's wrong. Okay. Yep.
So then the cosine squared x just cancels out.
Doesn't cancel out. We replaced it with a 1 minus sine squared. We traded it. Okay. And then last couple here. We're going to verify that sine squared times 1 plus cotangent squared equals cosecant squared. All right. At first glance, I'm like, oh, all right, I'll take your word for it. Anyone have an algebraic thought? We could surely distribute.
Did you divide by sine over x?
Ooh, you know what? I think I have a different idea.
You were sure it's a different idea?
skip this problem?
No, it's actually, this is really easy. I think I know a better name for 1 plus cotangent squared.
Yeah. You want to share it with me? Cosine. Cosecant
1 over
squared.
tangent.
Yeah, 1 plus cotangent is cosecant squared. Ta-da! So I'm going to say, all right, sine x times cosecant squared x. All right, sounds promising. Someone tell me. We can do a couple of different trades. Anyone have an idea?
No.
Can you trade sine for somebody? We don't usually do this, but could we?
Yeah.
What is 1 over cosecant?
You're so smart.
I'm going to put them over 1. And then someone said, I think it was Miss Jasmine said, well then one of the cosecants is going to cancel. And what do you have? We're done. Very nice. Oops, I kind of forgot what I was supposed to be doing over here. I was supposed to write equals cosecant. Now, did anyone think to trade cosecant squared for 1 over sine squared? That would have worked. So you would have done sine times 1 over sine, put them together. This one sine would have canceled. You would have ended up with 1 over sine at the end. And then what is 1 over sine? Cosecant. So, you know, it's fun. Everyone does them different. It's great. All right, let's talk about,
I think it was a hard problem like this.
It's not that bad. All right, hang in there, guys.
That's why we went, oh.
Now,
Kind of water.
I have a couple of thoughts. I could trade cosine for secant, but when I distribute it, I'd get secant squared here, and then I'd have to think really hard here. I could do this. I mean, do you guys want to do that?
No. Let's do the easy way.
We could just distribute the 1 over cosine.
Okay. Or not. The easy way.
I don't know.
Fast way.
Well, the fast way.
Skip.
Okay. Okay. Did anyone ever, I don't know if you guys are to this point in your math life yet. You have to be a special kind of person like me. Do you guys ever visualize solutions
No.
like in multi-steps?
No.
That's just me?
Yeah.
All right. Anyone of you ever dream about math?
No.
Is that just me too?
Yeah.
Okay.
I used to be a math teacher.
Okay. I think I'm going to trade 1 over cosine, okay? Let's trade 1 over cosine.
Those are classes you dream about us.
No, not you, just math. So I'm going to trade this for secant. So secant x distributed in, I'm going to skip steps for time, guys. I usually wouldn't do this. But if I distribute the secant into here, we're going to have secant squared on the first part minus,
Cosine.
well, hold on. We could do that, yes. But we are going to do that. So what Ms. Jasmine told me was trade secant right here for 1 over cosine. Is everyone following her thought?
I'm following my own thoughts.
No, she's 100% right.
Can you extend the
Yep.
I know, I like to, and then move, so like I
Whoops. You know what I need is graduated seating, like auditorium style. Like,
They should move this up. They say you,
Yes.
They say you think more if your eyes are looking up.
Oh yeah, or just
yeah, I think they should move it up too, but they, you know, whatever. They won't. Okay, right here. We're almost done, guys, promise. Secant squared x minus sine squared over, do you see what's on the bottom? Cosine squared? Can someone trade sine squared over cosine squared? Think about that.
How did you get that?
There's cosine times cosine on the bottom.
Tangent squared?
Yes, it's tangent squared. So we have secant squared minus tangent squared, and supposedly that equals 1. Look right here. Does secant squared minus tangent squared equal 1?
No.
Yeah. If you subtracted this over. Sure does. We're done. 1 equals 1. Check. All right.